Have you ever wondered why some weather events last just a few minutes, while others shape entire seasons? From tiny breezes to planet-wide climate systems, atmospheric events exist on a scale, both in space and time. Not all climate events are the same. Some are small and local, like a light drizzle in your town. Others, like hurricanes, wildfires, or heat waves, can impact entire continents. But how do we measure the scale of these events? Let's explore. Climate is like a giant puzzle, with pieces of all shapes and sizes. Some weather patterns span thousands of kilometers and last for months, while others exist only in your backyard for a few minutes. So, which do you think matters more in climate events? How big they are or how long they last? The answer is both. Climate scientists use two important measures, that is spatial scale and temporal scale. Spatial scale means how large an area an event covers. For example, the Ampon supercyclone in 2020 covered an area of about 700 square kilometers, that's bigger than Singapore. Whereas, the temporal scale is about how long an event lasts. Cyclone Freddy in 2023 lasted 5 weeks, making it one of the longest-lasting tropical storms ever recorded. There is usually a direct relationship between the size of the climatic event and for how long phenomenon occurs. It means that the larger atmospheric phenomena last longer, while smaller events happen more quickly. Now, let's break climate events into different categories, based on their size. At the largest scale, we have planetary climatic events. These affect entire hemispheres, or even the whole planet, spanning 10,000 to 40,000 kilometers and lasting weeks to months. The El Niño and La Niña phenomena change global ocean temperatures, causing droughts in Africa and floods in South America. Similarly, the fast-moving air currents in the upper atmosphere known as the jet stream influences weather across continents. Ever wondered why one winter is much colder than another? The jet stream plays a huge role. Here is a fun fact for you. Did you know that El Niño was named by Peruvian fishermen? The name means the little boy in Spanish because it often starts near Christmas. Next, we have synoptic scale events, which cover 100 to 10,000 kilometers and last days to weeks. These are the ones you often see on the news. Cyclone Idai in 2019 devastated Mozambique and Zimbabwe, bringing record-breaking floods. The US and Canada experience massive winter storms, known as nor'easters, bringing heavy snow and freezing temperatures. So, here is a question for you about the storms. Have you ever wondered how storms are given names? Why do you think that happens? Storms are named to avoid confusion when tracking multiple systems at once. Now, let's zoom in a bit. Let's talk about mesoscale climatic events, smaller but still powerful. These operate over 5 to 100 kilometers and last from a few hours to a few days. The difference between a cool breeze by the ocean and warm air in a valley, that's mesoscale climate in action. Another example is tornadoes, like those in Tornado Alley in the US or dust storms in India, can destroy entire towns in minutes. Here is a fun fact. The world's fastest recorded wind speed in a tornado was 486 km per hour, stronger than a Formula One car. Moving even smaller, we have local-scale climatic events, covering 0.5 to 5 kilometers, which is about the size of a small town. A single thunderstorm forming in the Amazon rainforest or over Sydney. Another example of local-scale climate is the urban heat island effect, where big cities like Dubai, Tokyo, and New York trap more heat than rural areas, due to concrete absorbing sunlight. Next time you visit a park or forest, check if it feels cooler than the streets. Why do you think that happens? And finally, we have microscale climate events, the tiniest but still important. These happen in spaces smaller than 0.5 kilometer and last from a few minutes to hours. The shade under a big tree feels cooler than standing in direct sunlight, that's a microscale effect. Even inside buildings, air conditioning and heating create different microclimates from the outside environment. Here's an interesting fact for you. In some skyscrapers, temperature differences between the top and bottom floors can be as much as 10 degrees Celsius. So there you have it. From planet-wide weather patterns to the smallest microclimates, climate operates on many scales. Each scale affects us in different ways, from global monsoons to the shade under a tree. Now, here is a task for you. Observe your surroundings. What microclimates do you notice? Stay informed about climate changes in your region. Be climate conscious. Your city's heat island effect can be reduced with more greenery. Now it's your turn. Which scale fascinates you the most? Let us know in the comments. And don't forget to like, share, and subscribe for more cool climate insights.